Well, hello everybody. I'm Tom Costan from American Air Arms, and today I want to talk a little bit about tension barrel systems. Everybody who follows air gunning probably knows a little bit about it, probably has an idea what tensioning is, but there's a lot of details to it that sometimes aren't considered. So I have a few things here to show you guys. Specifically, this is our Evol tension barrel system, very similar to the tension barrel system we do on the Slayer. But before we start with kind of showing you how all this works, talk a little bit about the history of tension barrels. So tension barrel's been around for a long time. My introduction to tension barrel was when I was shooting metallic silhouette, large caliber handguns. Dan Wesson at the time came out with this gun here, which was, I hate to use the word revolutionary, but that's what they called it. They were the first company that I'm aware of that introduced tension barrels as a competitive advantage into firearms. And on the Dan Wesson handgun, it has a barrel. It's very similar to the barrel that we use in terms of shape and function. It's threaded into the receiver here. There's a barrel shroud, and if you look at the end here, there's a tensioning nut. And the whole idea here for them was, if we pull all this together, we'll have a more stable unit. We get the shroud will help with strength because it's a larger diameter, and the tension will help with vibration because when we tension a barrel, we're pulling on it, and much like a piano string or a guitar string, the idea is that you take the natural frequency that it wants to vibrate at and you raise it into a higher region by stretching it. And when you're raising your tension or your harmonic into a higher region, you have a smaller excursion. So the higher the frequency, the more it moves, but the less it moves. And that's what makes the tension barrel, one of the advantages is you get less movement during harmonics. You still have the same energy and it's still vibrating, but it's vibrating at a higher frequency with a much smaller muzzle excursion. I hope that makes sense. So this is kind of where the idea came from the Slayer. So I'll put that aside. Now that we talked a little bit about the history of the tension barrel and kind of where it came from, at least in my experience, we'll talk a little bit about what the advantages might be for air guns. So we said one of the things we want to do with the tension barrel is we want to stretch it so its natural frequency is higher, much like a piano string. The higher it is, the higher the frequency. The higher the frequency, the less it will vibrate in terms of how far the muzzle is going to move. And that is what we're going for. The secondary advantage you get to a tension barrel system is, if you structure it correctly, you'll have a barrel, you have a nut that screws into your receiver. And I won't assemble this all the way, but I'll just give you the idea here. And you have a shroud, and I'll talk about the shroud in a minute, that will slide over that nut, and you'll see this is kind of an interference fit. We'll heat that up and draw the whole thing together. And then we have a barrel nut that goes on the other end. In our case, it also holds the moderator. So when we assemble our components, like I said, we have the nut on one end, the nut on the other end, and the shroud in the middle. The shroud is a very important piece, and the material choice is a very important piece. Now, we use aluminum, and we use a high-strength, high-hardness alloy for this particular part. And the reason we do this, not carbon fiber or other materials, is the thermal expansion rates of the steel versus carbon fiber or aluminum. Steel's going to have a higher thermal expansion rate. When it gets hot, it's going to grow at a faster rate than the shroud will grow, and when it gets cold, it'll shrink at a faster rate than the shroud will shrink. So the disadvantage of using something like carbon fiber is it's thermally almost perfect. It has very little coefficient of expansion, and what will happen with carbon fiber is when you tighten your assembly together and you tension your barrel, if it gets hot, your barrel's going to grow, and your carbon fiber's not, and it's going to get loose. So you won't have the same amount of tension as you would when it's hot as it would when it's cold. If you use steel, it's kind of similar in expansion rates, and that works. It's just heavy. No real disadvantage of using a steel shroud. If you use aluminum, it's perfect because it has a slightly higher rate of expansion, but it's also the tensile aluminum is a little bit less than that of the steel. So what happens is when aluminum heats up, its molecules just get close together and it keeps the same tension on the barrel. So whether it's hot or it's cold, your tension is very consistent. And that's why we use the aluminum shroud. There are ways you can get around expansion issues if you use springs and all kinds of other things with carbon fiber, but the complexity is just not worth the effort there. This turns out to be a very good material for that. So I'll show you a little bit about how we assemble these tension barrel units. We'll start with our barrel nut. This will have a little drop of blue Loctite on it, so it stays put for the life of the product. So what we'll do is we'll take a fixture like this, which is basically just cut from an EVOL receiver, and we'll screw our barrel in. You'll notice we use a lot of fine threads for assembly everywhere. A couple reasons for that, and it certainly isn't for speed of assembly, but it does give you stronger cross sections on most parts. So what I'm going to do is I'm going to thread this in here until it stops. And I'm going to take this pin here, which is the exact size of the barrel and the exact size of the chamber insert, slide it in the back, and now that's completely indexed. And we'll take this and we'll tighten this up until the barrel now bottoms out on our chamber insert. And we'll take this, put it in the vise, give this a little snug. We'll take our shroud, we'll just warm it up a little bit. Slide it over the barrel. And you can see this is pretty snug. We'll take a barrel nut, put it on here. We're doing this for video. We normally put a little drop of grease on there. We'll tighten this guy up. And that's it. We'll let this sit for about 30 minutes while the Loctite dries, and then once it's dry, we'll remove it and it's ready for installation on a gun. So I just want to talk a little bit about our test practices. A lot of what I do personally is R&D. I like to do a lot of testing of different bullets, different components, to see how they interact with each other. And that's probably the most time spent over anything, is going through and kind of validating that everything you're doing is working how you expect it to work. And that's not always the case. Sometimes we get surprised and the things we expect to do fantastic don't do very well. So here at the shop, we are fortunate enough to have our own range, and it's just a 90-yard range for doing accuracy testing, and a 300-yard steel we have up on top of the hill, which you'll see a little bit later, and we also have a 400-yard steel up on the hill there as well. And the reason we test at these ranges is if you don't test slugs at least 100 yards, or in our case 90, 92 or something, if you test them at 50, you may get very good results. The problem is you need to test them at a range where they get over apogee, and that's where everything goes wrong with the slug. The minute it arcs and starts to fall, that's when the tractability of the slug will either work or it won't work. So you'll see that, you'll start to see that 100-yard groups, and you'll really see how well that works when you're shooting 200, 300, or 400 yards. One of the things or I look for in slug-specific guns is, how do you determine which is the best slug and which one's actually going to work? And like I said, you can use 50 yards to get it on paper, but you got to go out to 95, 100 yards, and you'll see right away. You know, they'll either tighten up the group, it'll seem easy, or it'll be chasing all over the place. So what we just look for is, you know, if the slug is working well, you'll see either vertical or horizontal dispersion. That's either from, you know, the shooter or the wind. But when you see groups that are spreading out and they're round and they seem to be all over the place, that's a pretty good indication that that slug's not going to work real well. When you get groups that might be 1.5 inches, but they might be straight across, you can say, hey, that's the vertical dispersion is almost 0. That slug is doing something right. Now we need to figure out why it's moving left to right, which is almost generally the wind or the shooting. Almost all the shooting I do for testing is done off of bipod and table for precision shooting. We don't have a fancy 100-yard indoor range. I'd love to, but it's just not in the cards for us right now. But the advantage of doing it this way is it's real world. We're outside. We're kind of in the mountains. There's always wind. There's always temperature. Always a lot of real world variables. And when you can get a slug or a pellet to group really well out here in this condition, you know you've got something. So it's almost an advantage not to be in a perfect condition for doing this kind of testing.
That's pretty cool.
This is something we just made in the shop with the addition of a electronic hit indicator. So it's basically just a piece of 3/8 aluminum plate on a steel, piece of tubing. Nothing unusual about that. But from Magneto Speed, I purchased like a couple years ago this T1000 electronic hit indicator. LED impact makes the LEDs flash, but the design was such that it had a clear rubber prism that would be up above the target. And the concept with their hit indicator is if you miss and you hit the prism, it's soft rubber and your supersonic rifle rounds will go right through. But since we're not shooting supersonic rifle rounds, subsonic airgun stuff, they would hit the prism would fly off, and then you'd have to come back up here and fix it. So what I decided to do was ditch the prism and just drill holes that lined up with the LEDs in the plate and make them smaller than the smallest caliber we shoot, and it seems to be working really well. So now you don't have to worry about walking up here every time you shoot the prism off. A lot of what we talked about today is not just specific to the EVOL or the Slayer or American Air Arms. Airguns in general. So the goal here is try to just hopefully instill some knowledge and make it interesting enough for you guys to ask for more. So let us know what you want to see next.